Hey guys, so in my group our theme was solar energy. So I was the first person in our group to go in the Rube Goldberg project. So the way I decided to incorporate solar energy in my project was I had a light sensor attached to Arduino and I had a servo attached to the breadboard. So my intended goal was to, when I turn the light on, when the light sensor senses the light going on or off, the servo will allow this, it will turn 180 degrees. When I turn it off or on again, it will turn back the same way 180 degrees. So my goal was to have this servo act as a barrier for my ping pong ball, which would go down this ramp. So at first in my servo, it wouldn't work as a barrier as well. So I decided to attach a pencil to it, which acted as a good barrier for the servo. So my plan was to turn the light on or off. The ball would go down this ramp. It would go down, keep going down all the way through the ramp. I used chairs, couches to act as levels for the ramp to be really successful setup. And once it hit the end of the ramp, I had a candle and I had a little water bottle ramp to go down and make it go down smoothly. And this cup and this cardboard piece, that would act as barriers. So if it, for some reason, if it didn't go hit the dominoes right away, it would hit off the barriers and eventually hit the dominoes. Then it would hit these dominoes, go up the textbook, hit more dominoes. And then I added this car here to make it look cool, and I also add some time. But as this domino chain is falling down, it would keep falling down. I had a little turn here to add some time. Basically, the main goal I was trying to do was to turn this lamp on. So I tried many ways to turn the lamp on. I tried to, and the lamp is touch sensored, so it will turn on if you put your hand there like that. But it won't, sometimes it'll work when you put a water bottle, it turn on like that, or like a domino sliding. But it wasn't consistent. So my goal was to make sure that the lamp turned on consistently. And also in my original design, when I was doing this, I didn't have any engineering principle in my design. So I was thinking of how I could maybe incorporate a pulley or lever or something else that could be a good engineering principle. After deciding with my group and the professor and thinking what could be easiest in my ramp and domino setup, I decided to add a lever with a ruler that I got from Target. And this lever acted as this lever allowed me to do mechanical advantage. And so basically the main thing would be these dominoes would hit this water bottle. And because of the placement of the fulcrum, which is closer to the basketball, all I needed was a little bit of force to move the basketball. So when the water bottle falls on the lever, it moves the basketball just slightly to let it hit these water bottles, which I had two set up with plastic gloves on the top filled with water. And since the lamp is touch sensored, or like it's also weight sensored also, so I tested out many different situations of how to turn the lamp on. None of them worked, but as I thought of this idea, when it falls on the lamp with the basketball hitting it, it consistently turned the lamp on. So that proved beneficial to my project. So basically the ball would go down the ramp, hit the dominoes, and go on the lever, hit the basketball, turn the lamp on. And that proved to work consistently. Took a while to do, try to figure out which ones worked best, but in the end it worked well and I was able to turn on the lamp to lead on to my next team members steps, Sean having his lamp turn on in the beginning. Thanks guys.
When the lamp turns on from the previous step, the photoresistor detects this change in brightness and triggers servo movement. This popsicle stick is connected to the servo, and when the photoresistor detects a change in brightness, the servo moves up and the popsicle stick gate moves up, allowing these marbles to flow into the tube. The marbles will flow through the tube into this container, and in this container you'll see that there is a little car in there. I put that in there so that the container can have a bit more weight because the marbles themselves are not that heavy, so I needed a bit more weight in order for the marbles to direct the force of the pulley and the paracord downwards in order to pull on the paracord, which will lift the shoe. Once the shoe is lifted, it'll make contact to the bottom of this cardboard slab, and this ball with the angle change will flow down this ramp onto the net ramp. I've specifically angled this net ramp like so because when it makes contact with this cardboard piece and the ladder right there, It'll bounce over, enter this little plane, make contact with this tennis ball. The tennis ball will drop and knock into this first domino, initiating this domino chain. And once this last domino is hit, this domino is attached to this popsicle stick, which is preventing passage of this ping pong ball. That will be released and the ping pong ball will roll down this ramp, knock into this domino, which again is attached to this popsicle stick. Once that popsicle stick is removed, this ball will flow down the ramp again, and this is repeated 1, 2, 3, 4, 5 times. And the last step that I'll be passing on to Taryn will be a ball rolling down a ramp.
Hello, I am Taryn Mehta, and this is my Module D project, where I am a member of the Argon group. And I am the third step in this process, immediately following Shant. What Shant's final step allowed was a ball going somewhere, was a ball getting released and going downhill. What my thing does is it has the ball go downhill and into this cup right here, which it will then, with the pulley system I have set up, jerk all the way down and then knock into the Jenga blocks I have there. But first, let's talk about this pulley system right here. Basically, all I have is a ramp going down. The ramp is supported by this box and these magazines, which allow it to have a certain height, which will then allow the ball to properly go into the cup right here. Without this, the ball would not be consistent and not go into the cup all the time. How I have it set up allows the ball to go into there all the time. This paper right here allows for a smoother transition into the cup itself. Then we have the next step where the ball will go down, causing it to knock into these dominoes, or this train of CD case, video game case, and book, bigger and bigger things, which will then allow it to have a greater momentum and then move this out of the way. This right here is a solar powered car that I constructed out of scratch and got simply for this project for solar powered purposes, just so I can show one of the grand challenges of engineering. I want solar light to come in, power this, and allow it to move, which it will, after this obstacle is taken out of the way, which is removed by this whole thing. Now, after this car goes all its way, it's basically gonna pull this line tethered here and here, and then once it pulls the cloth of the tape of the rope it's tethered to, it's gonna simply show the photoresistor to the light, and then it will allow this servo to move and then hit a ball right here. And then that's it. That pulley will have a cup. That pulley will have a ball going into that cup. It will knock into it, having this swing back and forth, which will then push this out of the way, which will allow this car to go, removing a cloth from the servo for the resistor, and then allow a ball to move as pushed by the servo. Simple as that.
You can see as the ball rolls down that all of the side pieces, the pieces of plywood screwed in, were there to prevent the ball from rolling out because the groove wasn't ground perfectly well. And the last two wedges there were designed to be able to guide the last ball to hit, and even then it missed half the time. As the bucket falls, it pulls a lever which drops another ball into another bucket, which then is able to pull up on a lever to close a switch, which activates the servo. The original design had been, instead of a ball balanced on a lever, had been for a bucket full of water to pour water from into the other bucket to then engage the switch. However, repeated testing resulted in the bucket breaking off, and the bucket was eventually broken and I couldn't The block and tackle took a while to work out. I initially started with a 6 pulley system and then did the math and realized that while that would make it so that I only had to lift 1/6 the weight, I would also have to pull it 6 times as far. And doing the math for that realized that I couldn't make something 6 meters tall, so I stopped and went in a different direction. I then moved to a simpler block and tackle just using 2, realized that that would be too heavy, then moved to one using 4 pulleys, which means that I would only have to go 4 times as far, but would still get 4 times the advantage. So I moved that into the final system and built a whole rack that would be 2.5 meters tall to allow me to drop the weight 2.4 meters to be able to lift it 0.6 meters. Moving on from there, I was able to then finally connect all the pieces. And here's an early iteration of the last attempt. Sadly, the servo got left out in the rain and was destroyed so that I didn't have an opportunity to reshoot the whole thing together.